Okay, the next conic section that we're going to talk about are circles. And you know from geometry that a circle is a set of points equidistant from a given point. And that point that they're equidistant from, we're going to call the center. So here's what happens. If I have a point and I go the same distance all the way around and put a point, that set of points is going to make up what we call a circle. So it's not really a connected line, but the circles are so close, the points are so close together, it looks like they're connected. So whenever we talk about a circle, we'll start with one that has a center at the origin. And we'll have a point out here and make this R, and we'll make that point XY. So we're going to make a set of points that is R distance from the center. So it kind of looks like that. So if you think about this, if you wanted to talk about the distance or how you could find the radius from a circle that has a center at the origin, you could do the distance formula, R equals the square root of an x value, subtract the other x value, squared, plus y, subtract the other y value, squared. So that would be the distance of the radius, or the length of the radius. So we know then that x minus 0 is x, y minus 0 is y. So I could say that r squared equals x squared plus y squared. This is the standard formula for a circle. So if the center is at the center is at the origin, the formula or the standard form for a circle would look like this. However, we're not always going to have the center at the origin, so we just use 0 in this place and this place because that's where the origin was. But if the origin is not at the center, the standard form is going to look like this. R squared equals x minus h squared plus y minus k squared, and that is the standard form of a circle when h, k is the center. When you take the ACT, they're going to expect that you know that, and usually there's 3 or 4 circle questions on the ACT. So let's do a couple of examples here. Let's say I give you an equation that looks like this, y squared equals 4 minus x squared, and I ask you to draw this circle. So the first thing I would want to do is put it in standard form. So I'm going to move the x squared to the other side. So I have x squared plus y squared equals 4. So since I'm not subtracting any number from x and y, that must mean that the center is at the origin. And the radius is going to be the square root of 4. So the radius is 2. So I would go 2 units out on each side and draw my circle. So it looks something like that. Okay, let's do another one here. So let's write in standard form the equation of a circle whose center is at the origin. And there's a point on the circle at -2, 5. So I've got a circle that looks like this. Center's at the origin, and then at -2, 5, there's a point on the circle. So that means that however far the length is from there to there, that's going to be the radius, and that would be the radius all the way around the circle. So I know that because the center is at the origin, it's going to be x squared plus y squared equals whatever the radius squared is. So I just have to find the length of this radius. This is the point -2, 5. We could use the distance formula. The other thing we could do is note that this is we can make a right triangle here and know that the sides are 2 and 5. So this hypotenuse then would be 2 squared plus 5 squared equals the radius squared. So 29 equals r squared, so r equals the square root of 29. So the formula would be x squared plus y squared equals the square root of 29 squared, which is just 29.